What's that number, 1.96?
All right, so now we can hear the question, I think. Say it again.
I gotta find it.
This is not going to be a very good video, I can tell. Sorry, Bettina, we're at least trying to record it. So, is it in the book? Oh, good, because I forgot my book.
This is how you're trying to screenshot it? It's like you're trying to share your screen by taking.
I'm sharing half of it. What'd you say? Was it a good thing I didn't hear that?
I said I want a Belgian waffle.
You want a Belgian waffle? I can't help you with that. And you wouldn't want one of my Belgian waffles anyway. It would taste nasty.
Oh, yeah, because of your diet.
Yeah.
Dude, I like it out in my car today, and the whole parking lot smelled like pancakes.
I agree.
I don't know what it was, but like, now I really want some.
All right, we're back. You want me to just make up some data and make a confidence interval?
Yes, please.
Yeah, I can do
What's
it.
on the test though?
Which one's on the test? I don't remember. I just try and go. It's whatever it is. And it's nice when I do that because then,
She's looking for the.
So do you want to do a mean or a proportion? Which one do you want to do?
Two proportion.
I'm going to do a 2 proportion.
Yeah.
Okay, so the problem is when I make up stuff, then it's like, it could be weird data. Okay? All right, so let me see something here.
I love how you're trying to rig this.
I know, it's kind of hard to see, but I think, is anybody watching this? Does it look good on the YouTube? Anyway, so you can see this and hopefully they can. It's just so hard because I can't tell if my camera's focused or whatever. Okay, so we want to do a 2 proportion confidence interval. Okay, so here, let me do this. You guys were supposed to do a 2 proportion confidence interval, right? Okay, so we wanted to say there was is there a significant difference between men and women?
Hey, that looks actually pretty good.
Oh, good, thank you. Who want a primary challenger for President Trump. Okay, do you remember your numbers?
My numbers?
Yeah, do you remember the men and the women, or, close at least? So the men, let's do the support, oppose,
Ours on our social media.
and we'll
was
do the
huge.
women. You want to do yours instead?
No, just because there's like 80% of females that see.
Do you guys remember these numbers? It would be nice if they were, do you have a guess? Like a good guess? What'd you say, Sandra?
Are you talking about the final?
Your final project.
Data?
Yeah.
The data.
Do you remember off the top of your head what the numbers were, at least closely?
Yeah, like 552, probably at least.
552 men?
So we had 552 total surveys.
Remember the men and the women? Want me to just make them up?
Yeah.
Our females are at least 70 or 75%.
Okay, so let's go with, here, we'll just go 212 out of 300. And this one's gonna be, for your men and women even, we'll keep them different.
I have them here.
You got them? And the man will do 200, and we'll do 123. I don't know. I'm just making this up. Okay, so that gives us a total. In this case, 323 men were surveyed and 512 women. Whatever. Okay. So this is the data that we've collected, right?
Sure.
Okay. So what's the formula we're supposed to be using for the confidence interval formula?
It's a very long one. I read it.
P1.
P1 hat minus P2 hat plus or minus, what'd you say? Z
sub
sub alpha over 2 times
Square root
square root.
of
P hat 1.
P, isn't it just P hat?
P hat,
P hat,
Q hat,
isn't it?
that's what it is, yeah. I think it's different. Or-
P hat times Q hat, right?
divided by.
Oh, and I put that right on top of the formula sheet. Let's see here.
I see it, okay. Q hat, and then square root.
Oh, no, I did it wrong. You're right. This isn't right. I'm getting this mixed up with something else. So it's P1, it is P1 hat,
Yeah, I was getting confused.
times Q1 hat divided by N1 plus
Plus
P2 hat
times
times Q2 hat
divided by N minus, or N2.
divided by N2. Okay? So, given these raw numbers, we probably ought to start defining things. We want to know P1 hat, P2 hat, we need to know Z sub alpha over 2.
Yeah, that's the hard part.
That's the hard part. We need to know N1, we need to know N2, right?
So it's 1.96.
If we know all that stuff, then we can just plug it all in, right?
Yeah, so if you have your alpha.
Okay, so what's P1 hat?
So that's what P hat, right? You know P hat?
We don't need P hat for this formula.
For
For the hypothesis test, we would need. Should we figure out P hat anyway?
Yeah.
That's a good question, good idea. Okay? If we're doing the hypothesis test, we need to know P hat. Okay, we don't need it for the confidence interval. Okay, so how do we find all this stuff?
So,
X1
P1 hat.
P1 hat is,
the total support, for the men divided by.
we call them the men, so men are the P1s, okay? So the total support divided by
the total.
the total men, okay? So that's 38%. Same thing for women, 212 divided by, these numbers are way off, right? You guys were like 75%, we're at 38 and 41. Whatever.
Yeah.
That's what happens when you make it up.
That's right, I'm sure.
Okay? So this is whatever it is, clearly fake data.
Z sub alpha over 2.
I mean, Donald Trump will love it, right? If I start
Isn't
talking
it
about fake data.
1.96?
Yeah,
Is it 1.96?
Yeah, because isn't our alpha going to be 0.05? It's not stated.
It's not stated, we assume it's 95%, right?
That's what I figured.
So you actually memorized that?
I knew where to get it on the chart.
Okay, do you know where to get it on the chart?
It's on the Z chart over on the
Do you
side.
remember how to get it without the chart? It's on your formula sheet.
I'm trying to do that away.
You threw that away, you didn't need
I threw
it?
away the first sheet and I got the tables. So like,
Yeah, the tables. So you still have it.
oh yeah.
It's on your tables.
Thanks.
Oh, the formula sheet has the formula, the name of the formula though.
Yeah, that's,
Even if it's a
Yeah.
bad formula sheet. What's the formula? At the bottom. All your formulas, all your Excel formulas are at the bottom. Norm, S, inverse.
Oh, yeah, I have.
Oh, yeah, I
That
guess
was my
with it.
question. What do you use?
What do you use for the probability? Are you recording too? Yeah, you can record. I'm recording. What'd you say?
I said, I repeat, I cannot find the formula. This to find the whatever,
What do we put in for the probability? That's not on your formula sheet.
for the.
What would Rick do?
draw a
How
picture.
come you guys don't ask that question? Here, let's roll this down a little bit. So, Oh, I can't see. There we go. That's not a very good
One of
picture.
your
of me.
major questions, what was Rick do?
Yeah, I should put that on that test.
And I would still somehow miss it.
Okay. So we're going to draw a picture of normal distribution, because this is a normal distribution. Okay. Now what? What else do I do with that? If we want a 95% confidence interval, the 95% is in the middle, right? Okay. Now, what does Excel always tell you? Always tells you the area to the left. Okay. So there's two ways we could do this. If we want to find the negative value, how much area is to the left?
2.5.
We could put in 0.025, leave it as a decimal, remember? Okay. If we want to, so that'll give us probably negative 1.96 or something very close, okay? If we want this area, what do we put?
1.025.
No, we already put 0.025. How much is to the left of here?
1.96.
What's the percentage?
97.5.
97.5. So here, we're putting 0.975 to the left. And that'll give us a positive 1.96, theoretically. Okay? Let's check and see if... Oh, that's pretty funky, doesn't it? Let's see what happens here. Okay? So if I put 975, look at that. And if I do norm S inverse 0.025, it gives me the negative value of that, okay? So, Aaron, are you going to remember to ask yourself WWRD tomorrow?
Yeah.
Or today even?
Is it okay if I just-
Are you taking the test today?
No, I'm only taking tomorrow.
Tomorrow. Okay. Are you going to remember that question?
Yeah.
When you get stuck, you'll say, what would Rick say?
I'll say,
No, he would draw a picture first so he knew what to put in there for his probability.
Oh, yeah, sure.
Okay, that's the whole reason we're doing this. Because if you want to do the positive value, you're going to want 97.5% of the left. Okay?
And just a reminder on the standard deviations, it's 68, 95, 97.5.
99.
99.5.
Yeah, so it's the 68, 97, the 68, 95, 99. Rule.
99, okay,
Yeah. It's 99.7 actually.
99%. Okay.
And why do we put 0.9?
Why do we put it on 90? Put that here? Because we want a 95% confidence interval, right? Okay, so we want 95% between here and here. But in order to get this value, I have to include the left tail. So 2.5% plus 95% is 97.5%. Okay? Yes, Aaron. Okay?
So in reality, here's alpha divided by 2, 1 minus that. We get the same thing.
Okay?
You're shaking.
Yeah.
Because if alpha is, say, 10, I would say, okay, then on both sides it'd be 5.
5%, right?
And then you're really just subtracting that by 1, so you can get that number that's at the top.
Right.
Yes. All right, I'm good. Yeah.
You good? Okay. You gonna ace my test?
Most likely, I'm not gonna lie, yeah, I'm right.
You're gonna ace it? Nice. I'm glad to hear the confidence.
Confident, I like it.
I got a 99.
Hopefully that's not
confidence interval
overconfidence.
that I'm gonna get at least 2 points on this test.
All right.
You are.
Okay, what's your N1? Your N1 is
323.
323. Your N2 is 512. What's your P hat? If we were doing this, we only need this for the hypothesis
Add
test, right?
N1 and add N2.
So use parentheses. N1. Sorry. No, it's not N1. It's P1.
You might want to do, yeah, that,
So we're assuming the supporters here.
Yeah.
X1 plus X2
And then divide that
divided by
N1 plus N2.
N1 plus N2.
Yeah.
Okay?
So like that.
All right, so our p hat is about 40%. Okay? All right, so now we need to do the lower and we need to do the upper. Okay, I've got my formula there. So Aaron, take it away because you're going to ace the test,
All right.
Mr. Confident.
So P1 hat,
P1 hat, which is
which is 23.
0.38
So minus
minus
P2 hat
P2 hat.
equal plus,
What'd you say?
equal plus.
Oh, I did put plus, sorry. Thank you. Minus
0.41.
0.41. Okay. Minus, because we're doing the left lower first.
1.96.
1.96. Should we use this one here? That's the better one to use on the computer, right?
Yeah.
Okay.
Times.
Times. Huh?
We need our Q1 hat.
Oh, we can do that here.
Right.
Okay. Times what?
Square root
Square root of
P1 hat
P1 hat times
1 minus
1 minus that
divided by
divided by
N1,
N1, which is
which is
323, plus
P2 hat
P2 hat, which is
4
0.414 times
1 minus that
1 minus that
divided by
divided
12.
by 12. Okay. Do you feel comfortable doing this with your calculator?
No.
No.
Yes.
Do we need to practice?
I need that different.
Yeah,
we're
we're
gonna-
gonna calculate wrong. I have to go back downstairs and go.
Okay, well, what if it's on the paper test?
Oh, tomorrow. Oh, yeah, after
Okay,
that.
so you should practice these on your calculator and on the computer because you can see it either place. Okay, so the answer is negative 10%. Okay, does that seem like a reasonable number?
No.
Yes, it does.
Well, for me to pay the sure.
Normally, we might say, why is it negative 10%? But why is it negative 10%? We're taking the men minus the women, right? 38 minus 41, that's going to give us a negative number. We're doing so because we're doing a difference, negative is okay. Normally, negative should be a red flag. But in this case, it's okay. Okay? Now, how do we copy and paste this really quickly usually? Don't copy, can you copy it here? No, because it won't work, right? If you copy it up here,
I'd be down to go to the bar.
can you see this, by the way, on the videos?
Not the top part.
That's what I was afraid of. Can you see it now?
Give me a second. Yeah, now it's good.
Now it's
It's
good?
like on a 2-second lag.
Okay. So we're going to copy that, and we're going to paste it. Hopefully we get the same answer. What's the only thing I need to change?
Change that minus 3 plus.
The minus K6, right? Should be a plus K6. Okay, everything else is exactly the same. Okay? So I got this between negative 10% and 3.5%. Okay? So there's two different confidence statements I'd like to be familiar with, but I do want to answer this question. I'll try to spell this right. Is there a Is there a significant difference between men and women who want a primary challenger for President Trump, according to this data?
No.
Ooh, we better vote. Because I saw a head and I saw a no. Okay? Who says yes, there's a significant difference? 1, 2. Who says no, there is not a significant difference? 1, 2. And who didn't vote? The other two, we got a three-way tie. Okay. Why did you say there's a significant difference, Alex?
My thought is because both of those are lower than our alpha.
Because both of those are lower than alpha, and you said there's not a significant difference because why, Aaron?
That's a zero.
Because there's a zero in the interval. Okay.
Fine.
Who's studying with Aaron tonight? Aaron was right. There's a zero in your interval. We're not comparing this to alpha.
Oh, that's right.
Okay, this is not what we compare to alpha. So, because there is a zero in that interval, one's negative, one's positive, zero would indicate there's no difference, right? Zero is in that interval. Okay, so Aaron, pat yourself on the back, dude. That was awesome. Okay,
Nice.
Everything's something, yeah.
all right. So,
I had doubts.
so what's the conclusion?
I'm not familiar with that.
Oh, come on, you just got that right.
Yeah, I know, but I'm
You
not-
gotta, you can't trip at the finish line.
I know it's something between.
Something between. No, I don't want, so you can do that, but I actually don't want you to. I want you to answer this question. Is there a significant difference?
There is not.
There is not a significant difference
Between. Is that something?
between
Negative.
men and women's support of a challenger for President Trump and Republican primary.
Okay, that's cool. I can second that.
You can do that?
Yeah, I can do that.
Okay.
See what you're saying, then that's going to be.
Now, I know with the other ones we were saying we're 95% confident in between whatever, no whatever. You can do that, but this is actually a better, this is more clear conclusion, right? It answers this question a lot better. Okay? Okay? All right, what else we got?
So what are the criteria for determining whether something is significantly confidence interval? Is it just that zero is not containing that value?
Okay? So the question was, in case you can't hear, what is the criteria for defining if something is significant with a confidence interval? Is it zero? Now, it's only zero if you're subtracting either your p's or your mean. So it has to be a two proportion or a two mean test. Okay? If you're doing a two proportion or a two mean, we're looking for zero. Okay? If it's a one proportion or one mean, zero doesn't matter. Okay? What matters? Tangentially alpha matters, but no. Your null hypothesis matters. Is your null hypothesis
In your value?
in your confidence interval?
Okay, and if it is in there, then it's not significant because of confidence interval has that inside.
Yeah, if your null hypothesis is in your confidence interval, then then your sample is not significantly different. If it's outside your confidence interval, then it is. So do you want to do a one proportion or a one mean?
Sure.
Okay. Okay, so this one is two proportion confidence interval. Okay. Now, should we go with a mean this time? One mean.
And, proportion, two proportion, and is there such thing as a two mean?
What'd you say?
Is there, we never do a two mean, two mean.
We can do a two mean also. You want to do a two mean instead of a one mean?
No, we'll only do one mean, so I don't understand. But the only difference is you and me. That's the only difference between the two. like the equation is the same, but the difference is the letters. Okay. You know what I'm saying? Like she had,
No.
and,
A mean and a proportion are different,
yeah.
so those are different.
Mhm.
So those are not the only difference. A mean and a proportion are the difference.
Yeah.
Okay, you can have a 1 mean, or you can have a 2 mean, or you can have a 1 proportion, or you can have a 2 proportion. So I'm not sure I understand your question.
I'll ask you afterwards.
Okay.
Yeah, I'll ask you.
All right, so let's do a 1 mean. We're going to do a bunch of random numbers. Christian, give me a random number. Random between 8 and Chandler, give me another 42. Okay.
I thought we were inventing it too.
All right, so we got a bunch of numbers here. Okay. Now let's make up a null hypothesis. We don't even know what the mean will be. Okay. So what do you think the mean should be? With a bunch of random numbers between 8 and 42. Should be in the middle, right?
Trying to do it.
This is just random number.
These are random numbers.
Can we just find it?
So we can find the mean, but I want to come up with a null hypothesis. Since this is a fake example anyway, you didn't give me any good problems.
25.
25. You understand mu equals 25? Okay, we're just making that up. Normally you'd need more. You collect real data, but anyway. So we're going to pretend that the mean is 25. Okay, let's find out what the mean is.
I need to see if I'm getting that in the system.
Oh, sorry, hope everything's okay. Okay, you'll be watching later, hopefully. So the mean in this case is, okay, so the interesting thing would be, so at this moment, do you think there's probably going to be a significant difference? Probably not, right? Now we'll do the math and see if you repeat that idea, or if you change that idea, or if you get confused by that idea. Okay? So remember, we're comparing this mean with that mean. So we're going to do a confidence interval, right? What'd you say?
Alternative.
What's the alternative?
Is it less than?
Well, equal to. Yeah.
But what if it less than?
You could do less than.
Oh,
But yeah. Oh, the numbers just changed.
oh, because you didn't.
Oh, I forgot to copy it. Let's copy. Oh, I don't want to do that again. Let's do this. I don't want to copy here. We're going to copy because it might change again. Copy. Yeah, there we go. Oh, see, it just changed again. 27, 23, it's whatever it is. Paste special. There we go. Okay. All right. So we want to do a confidence interval for one mean. Okay. This is all the information we have. So how do I do a confidence interval? What'd you say?
We want to find the numbers.
On the numbers, we got our numbers right here. I don't know what you mean.
Oh, yeah, that's all the numbers.
Those are all the numbers.
Like, we need our N.
We need our n. N would be a useful number to know. Okay. What's my n? How do I find that without counting?
Just highlight all
Highlight all
of them.
My n happens to be 20.
Alpha.
Alpha
105.
105.
In this case, I feel it's 25, right?
Mu is 25 according to our null.
Yeah.
Anything else I need? Is this a z test?
Yeah. Oh, no, that's the counting.
Or is it a z confidence interval?
Yeah.
Should we vote? This is a z confidence interval. One, who says it's something else?
You got some of it is, it's not T or the other.
Which one is it, Chandler? Good question. Okay,
That's a good answer, right?
you need to know this by test time. And that's either today or tomorrow. Definitely by tomorrow. At the latest, 10 a.m. tomorrow.
Wait, but we don't know our standard deviation for population, right? So that
T-test?
Wait, what?
Mine is a T. You don't know sigma. Bing, light just came on, okay? So it's a T, not a Z.
Flat. I mumbled that.
Okay, he mumbled it right before you. Did you hear him?
What's that?
Did you hear him?
No, I got it in my notes.
You got it in your notes. Oh, darn, I can't use those tomorrow, though.
I feel good about this.
Standard deviation, right?
So this is STD
Dev,
S.
dot S,
Sample.
it's a sample. All that. And maybe I should move this over here so we don't have to keep going to the bottom. Okay?
Is it still?
We have the standard deviation of population.
Yeah, not.
Oh,
sample.
I see what's happening. I see what's happening now. Okay. Okay.
Okay?
So population is, okay.
So we need our
I
T
got
set
you.
alpha over 2.
I got
So we need our T sub alpha over 2, right?
you.
I don't have to.
Don't have the chart. How can we, and you didn't memorize the chart?
No.
What's
Oh,
wrong
wait,
with
so
you?
this is, oh, no, it's not that. It's not T dot dist, is it?
It's not T dot
That's what we
dist.
would get when we have our P value.
When you have your P value, you use T dot dist.
That's right.
What's the opposite?
See that?
T dot inverse. Very good, Aaron. Aaron's on fire today.
Yeah, just take your test today.
Oh, man.
Which one? I got 2 choices.
This is,
It's only for one meeting, right?
Is it a 1-tail or a 2-tail?
I think it's a 2-tail. It's just one tail. That's
Because confidence intervals are always 2 tails, right?
What?
So what do I put in for the probability? The question.
Draw a picture.
Not it.
Jordan, how come you're not asking the question?
What would Rick do?
What would Rick do?
I have this as a sitting here to do it.
You guys, aren't I in your dreams yet? Haven't you started dreaming about class yet?
I actually did.
If you guys haven't been dreaming about me, you're not studying hard enough.
Trust me, they just have them in nightmares because I'm looking.
Let's
at
draw the
where I'm
picture.
gonna go.
Let's see here. Okay, here I'll have to erase my other picture. This is the wrong picture. Okay, what am I drawing a picture of? Nope, I'm not drawing a picture of.
Oh, so it's a T, because it's the one that goes down to the degrees of freedom and whatever.
It's a T distribution, okay? And everybody can clearly see that's different than normal, right?
Yep. I see it too.
Okay, it's got fatter tails,
Yep.
okay? Now what?
Degrees of freedom are 19.
Degrees of freedom are 19, we should have marked that down, but I'll write that down for now, okay? And then,
We want the space in the 2 tails on either side.
what do I want in the middle? I
95%.
want 95%. Okay, how much do I want in the 2 tails?
2.5.
I want 2.5% in each, which is a total, so your alpha equals a total in this case of 5%, right? Okay, so that's what I'm putting in. Alpha is 0.05. Okay, let's see if that goes back to the table. Uh-oh.
There's some serious lag on this here.
Hopefully you can tell me. Good.
It's lagging. Yeah, we're good.
Okay. So my probability I put in here, Aaron, is 105 because you drew your picture. And you remembered to say, what would Rick do? Okay, on your degrees of freedom, 19. We probably should have included that earlier. Degrees of freedom is 19. Okay, so that gives me 2. So that's about close to 2, right? If that was a Z, it would be 2, right? 95% is 2 standard deviations. It's 2.09. So that seems roughly correct. Okay? All right, so Chandler, what's the formula? X bar plus or minus P sub alpha over 2
times sigma over square root of
sigma.
not sigma, that's your. Oh, that's your. Yeah.
Write down the formula first, and then you know you got it all.
This is the mean, correct?
What's the mean?
X.
S is not the mean.
What is that?
What is that?
is
Standard deviation.
All right, cool.
What's the mean?
The mean is,
What he said. X bar. Okay. So lower. Should we ask Jordan to do it?
No.
Does Jordan want us to get a bad score tomorrow?
All right, we got the 23.35, plus
23.35
we'll go with minus first.
minus first,
And then you have your 2.09,
2.09
and then divide, well, actually times
Times.
your 10,
10.02.
yeah, divided by your square root of 20.
20, there's my 20.
And these formulas are on the sheet, right?
Formulas are on the sheet.
Awesome.
Things from the quiz today, some of you are having a hard time picking the right one. You can nail it, Christian? You're gonna go to church and pray about it? I hope God answers your prayer. Okay? So that gives me 18.65. I'm gonna copy, I'm gonna paste it, I'm gonna change this, there was only one minus in this case, to a plus. It's gonna give me 28.04. So, Christian, you just prayed, and God said, is there a significant difference between my confidence interval and my null hypothesis? No. There is not a significant difference. Finish it again. There's not a significant difference because 25 in the confidence interval. I do believe God answered your prayer this time. Okay?
Christian,
I hope so.
with like something like this, as long as the number is in between those question jiggers,
What did you do?
the lower and upper.
As long as the null hypothesis, which is 25,
So if it was like 1 to 1,000, right? Something crazy like that.
if the confidence interval is 1 to 1,000,
Yeah, so lower and upper, lower was 1, and upper was 1,000.
okay?
And the the null hypothesis was like 50, then it wouldn't be, it still wouldn't be a significant difference. Because that's like that.
Okay. Now, what if my mu, okay, so let me ask this question. What if my mu is 30? Would there be evidence of a difference? Yes. If my mu is 15, would there be a difference?
Yes.
Yes. If my mu is 20,
No,
no difference. Okay? If my mu is 28,
no difference.
no difference. Okay? Close to, that'd be like border.
Find the upper and lower quartiles again.
How do you, oh, that's a good question. Find the upper and lower quartiles on this. What, do you want to do it with the computer?
Well, my computer's frozen, so.
Well, yeah, I'm sorry. But Can we do it with the computer question? Better question. We want to find the 5-number summary. Find 5-number
Our final was
summary.
and that was on one of our, that was on our very first.
Oh, the in-class one.
And
No, the.
fences.
Very first final for our first exam was on there.
Oh, that was so long, 6 weeks ago. Okay? All right, so how do we find the 5-number? What is the 5-number summary? Jordan, what's the 5-number summary?
You grab 5 numbers and group them, I don't know. Get 5 groups of numbers.
5 groups of numbers? No, it's just 5 numbers.
The minimum.
Minimum?
Oh,
What'd you say?
Q1.
Quartile 1.
The median, no, median, it's median.
Which one is it?
It's median.
Mean or median? Are mean and median the same T, but they're not always the same? Is it the median?
Yes,
You sure?
yes,
Are you really sure?
yes.
Good.
They'll get 100% if I say.
Median,
Me
quartile 3,
And
Max.
max. Okay? How do we find these?
you can use the same thing for all of them.
You can use the same formula for all of them. Which formula is that?
So it's equal to, or equal quartile,
Quartile, which one?
bottom
The
line.
bottom one. Only use the bottom one.
And then we need all our data,
Highlight all my data.
and then min, comma,
Nope. Can you F4 that? Is that a good idea? Who thinks that's a good idea? Who thinks that's a bad idea?
I think it's a good one.
It's a really good idea. An excellent idea. Okay? Yeah. F4 that right now before you even press the comma, because if you press the comma first, then it's going to not work right. Okay? And then what?
zero.
We'll put the 0. Whoops, I meant to put the 0. Okay?
Okay, I know my screen's frozen, but you might want to try moving that over just a little bit that way, because last time you cut off that cave.
Is anybody watching it? It's hard for me to tell, but hopefully that's
Yeah,
good.
hopefully you're good.
Okay? Then I'm going to copy that formula down, and hopefully I get 8 every time. I did. If you don't get the same number every time, you made a mistake. Okay? Now I need to change the second 8 to a, it's a 1, and that's a 2,
Oh, okay, I'll see.
and a 3,
On the side of it.
and a, oh, you did?
It takes a little bit longer,
Yeah,
not that much
It's
longer.
faster. Okay? So there's your 5-number summary.
It doesn't look like it.
What are the fences? Or maybe I'll just do it this way. What's the lower fence? And the upper fence? Fudge? What'd you say? In order to find the fences, we need to find something first, right? We're missing a step. What do we need to find before we find the fences? Interquartile range. Hey, you guys are studying, I can tell. Too bad Dalton's not here. We should have an extra credit quiz for Dalton not being here, huh? And Bettina. Because then she's gonna be mad. She's gonna be like, no. Okay. What is it? Louder? 31 minus 17. Q3 minus Q1. Okay. Interquartile range is 14. And lower fence is
17 minus
Q1 minus
1.5.
1.5
And then times that by 8.
times the interquartile range. Okay? So -4, and the upper fence is Q3 plus 1.5 times that 14 again. Okay?
Clearly you have no outliers
Why do I have no outliers?
because it was.
Because everything's less than 52 and everything's greater than -4. Okay?
Thank you.
All right.
Question, I almost wrote that question on the exam.
You gonna ace my test?
No.
Probably not that. Probably not that.
I'm just being honest.
I might get a C. I'm cool with that. I'm upset.
When I hear ace, I hear 100%. That doesn't have to be on stuff that I completely understand.
How many questions are in the written?
Not enough.
Uh,
Sorry, I like your written
About
test
20,
over
I
your
think.
computer
I
test.
can't remember. I think it's about 20.
Like, you kind of split up evenly between the.
We just, probably 5 questions on the computer. It'll probably take you about 8 hours.
New stuff, right?
No, it's comprehensive.
It's comprehensive, yeah. The computer's gonna be more of the latter stuff, but the paper will be everything.
Doesn't sound good. Everything.
Okay?
So computer stuff is only the last 2 chapters.
No, it's not
Mainly.
only.
Okay. Mainly.
So you still have to know, like, how to get your
Yeah, we'll
standard
still do standard deviation, we'll still do correlation. In fact, those will
Your
more than likely be computer questions, ordinary least squares regression, that kind of a stuff. We'll do confidence intervals, we'll do hypothesis tests.
Yeah, when it comes to the very end of that, when we're done with.
Graphing, can you make a pie graph, a bar graph, line graph?
Percentage scheme at all.
Say it again?
At the very end, we don't have to do the percentage scheme at all, that we're.
Hey,
I
having
understand.
confidence that this is this, we just word it that way.
No, I've been leaving it out. Yeah, we are 95% confident.
Do that, you're forgetting how to.
Scatter plot,
Well, I know how to make a scatter plot, I just don't know how to put a
Okay.
line.
this is gonna be X, Y, equals ran between 5
Well, you
and
needed,
15.
you needed to see on this test, well, you found out that all our scores for representation was like 40%. Like, that's bad.
Okay, so we're just making a scatter plot, right? Because we've only got like a minute left.
I know, I'm just trying to figure out how to
Insert, tell me what to do.
go to scatter plot.
Scatter, boom. Okay,
So spread and grab the paintbrush.
and we need to put the line on there.
Yeah, I don't know how to do that.
How do we do that? Grab a point, any point will do. Right click,
Add trim line.
add train line. My dad would say, if it was a snake, it would have bit you.
Alright,
Okay, and then what?
maybe it's not.
We're assuming it's linear. Anything else I want to press here?
We'll display the equation.
Display the equation and the R squared, those are useful usually. Okay, and then, there you are. Now make this, label it properly, this is obviously fake data. What do you think of that? Is that good correlation?
No.
No. Terrible model, right?
You're not even a percent.
Okay, it has less than 1% variation.
I mean, that's a lot better than, or that's a lot worse than yesterday's at 9%.
Yeah. Okay,
Okay.
all right, and of course we'll label it with the plus sign and whatever, but we're out of time. Okay? All right, so I will post this spreadsheet. And then, so Jordan, you taking it, anybody else taking it today?
No.
Just Jordan? Jordan's the only one that wants to save money?
I'm the only, that's the only reason why, is I'm so dirt broke.
Okay, use this one.
Okay. So
Okay, do you want this recorded?
that doesn't have to be.
Do you want me to turn it off? Okay,
Are you gonna post the sheet?
am I gonna post what?
Yes, can you please post a sheet since my
Here's
computer
today's
crashed?
sheet.